In this lesson, we will be factoring polynomials. So this is the beginning of a big section in algebra, and we're going to start by looking for common factors in each of these separate monomials. We call this a polynomial because there's many monomials being added or subtracted. But we're going to look at each separately and then combine them and see what is common between these. And so what I would like us to do is look at each part of each separate monomial. Look at the coefficient first. So here we have 15, and then look at this coefficient. Here we have negative 5, and then here we have an a, and here we have an a squared. Well, typically we want to keep these in what we call descending order. So remember, descending order is when we go from highest exponent to lowest exponent. So let's go ahead and rewrite this as negative 5a squared plus 15a. So I like to keep the term that has the highest exponent first, because that way it will be in descending order and it'll be easier for us to factor later on. It'll help us figure out what it has how many a's we should be pulling out, and so on. And so always commute the sign that's in front of the term with the term itself. So now let's take a look at each of these terms. Let's see what we could divide these by, and that's what we're going to end up factoring out. And so typically we want to keep the first term positive, so I'm going to take out a negative, and then I see that both 5 and 15 can be divided by 5, so I'm going to take out a 5. Okay, so we're going to take out a negative 5 from each of these. And then over here we have an a squared, here we have an a. So you're going to take out the biggest number of a's you can. See, I can't take out any more a's from this one, because if I did, I would have an a on the bottom of the fraction, left on the bottom. See, if I took out a squared here, I would have a's on the bottom of the fraction, but then it wouldn't be a monomial, because a monomial can only have a's or any variable to a positive power. It cannot have negative exponents, because then we'd be dividing by a variable. We can't do that. And so what we have to do is only take out the number of a's which lead us to just positive exponents. And so I'm going to just take out one a from each. So you notice how the common factor is negative 5a. That's what I'm going to be pulling out. So I'm going to take out the negative 5a, and then I'm going to do the division here. So I do the division, see what's left over. See, these negative 5's cancel. This a cancels out one of the a's on top, leaving me just with one a. And then over here, same thing. Negative 5 goes into 15. Careful on the sign there. Negative 3 times. So it's a negative 3. And these a's all canceled out. So that's it. That's as far as we go. And this is our answer right here. We're not going to go any further than this. See, basically we're working backwards from what we were doing before when we were multiplying. See, if we multiplied back out, we would have negative 5a times a would make the negative 5a squared. And then if we multiplied the negative 5a times the negative 3, we'd end up with a 15a. Right back to where we started from. And so that shows that we did do the factoring correctly. And so we're trying to factor it, and eventually we're going to solve for variables once we have an equal sign. See, once we have a term without the a squared attached to it, we can go ahead and solve a little bit easier. Even if it doesn't, we can still solve it. So that's what we're leading towards, is being able to solve for a. That's why we factor. And so we'll see that later on, but for right now we just need to work on this skill of factoring. And so first thing we'll do on this next one is look to see if it's in descending order. It is in descending order, highest exponent to lowest. So now we go ahead and look to see what we can take out from each of these terms. So we look at the 10 and the 3. Well, 10 and 3 don't have a common factor, just 1. And so we can't take out any numbers, but we do have some g's we can take out. Here we have 3 g's, here we have 1 g. So if we take out 1 g here, we're still left with no g's on the bottom of the fraction, so that's good. See, this g will cancel out this g, and so we're left with no more g's, and that's fine. We'll take out a g from this one, and here we're left with just 2 g's on top. So that's our common factor. That's what we're going to pull on the outside, is a g. And what's left over? Well, we have a 10g squared left inside as the first term in that binomial. And then over here, we canceled out the g's, so we're just left with that negative 3. And that's our answer. So again, all we're doing is trying to factor it down so we take out what's in common between the terms. And so we take a look at this next one. We have to look for the biggest factor that goes into these numbers. Again, we check to see if it's in descending order, and it is. And then we like this term to be positive, so we're going to take out a negative from each of the terms and take out the biggest factor. So the biggest factor of 12 and 18. Well, we have 2 goes into each number, but I also have a bigger number. See, 3 goes into each number, so that means 6 goes into each number. So let's take out a 6, the biggest factor. And then let's take out the number of x's that will make it so we have no x's on the bottom of the fraction, but take out the most we can. So here we have an x, so we'll take out 1x here. And that's all we can take out is just 1x, because if we took out more x's, if we took out 2 x's here, or even 4 x's, this would leave us with x's on the bottom of the fraction. And we can't have that. Otherwise, it wouldn't be a monomial or a polynomial. And so we go ahead and do the division. So again, negative 6x is what goes on the outside of the parenthesis. And then inside is what we get when we do the reducing. So let's go ahead and do some reducing here. The negative 6 will cancel out the negative 12 and make 2. So we got 2 left. And then we cancel out some x's. This x will cancel out 1x here, making 3 x's. So 2x to the third power. Do the same thing here. Negative 6 goes into negative 18 3 times. So it's going to be a positive 3, because the 2 negatives cancel. And we cancel out these x's. And that's it. Nothing else. So we've got our answer right there. And so again, the whole key is that we're just factoring out the common factors and leaving it in a form that looked like what we had to end up doing as a problem in previous lessons. And so if we wanted to, we can multiply back, and you get right back to the same answer. But the point is to try to factor. And again, the reason why we factor is because later on we'll find out that we can solve for x when we have an equal sign. Once we have an equal sign, we can solve for x and get values. And that's what we're leading towards. So here's another problem. This one has a 3-term polynomial called a trinomial. So again, we're looking at dividing each of these numbers by a common factor. We look at all of them, and they are in descending order, so we're good to go there. So we look for the common factor. Well, does 12 and 6 have a big factor of 6, but 8? Nope, 6 doesn't go into 8, so we have to use something smaller. And so 2 is the number we can use, and I'm just using a positive 2 because this is a leading term. This is the leading term, the one with the highest exponent's already positive. Well, how many h's can we pull out? Well, we have 1 here, 2 here, 3 here. So we can only pull out 1. Because again, if we pulled out more, like if we pulled out 3 h's, we'd have h's left on the bottom. And you can't do that. Otherwise, it wouldn't be a polynomial. And so we can only pull out 1. So now we'll go ahead and do some reducing. So the 2 goes into 12 6 times. So we'll go ahead and put that 2h on the outside. And then figure out what our answer is here. So 2h was the common factor that goes on the outside. 2 went into 12 6 times. This 1h will cancel out 1h here, leaving us with 2 h's. So 6h squared. Well, this 2 will cancel out this 8, leaving us with 4. So it's a positive 4. And then you count up how many h's. 1h here will cancel out 1h here, leaving us with an h on top. And then over here, we have 2 goes into negative 6, negative 3 times. So minus 3. And then you count up the h's. Well, this h here will cancel out this h, leaving us with no more h's. And there would be our answer. Well, let's take a look at another one here. This one, again, there's 3 terms. They are all in descending order. The constant, the number without the variable, always goes last. So let's take out the common factor. This one is positive. This is our leading term because it comes first. It's got the highest exponent. That's why we have it there. And it's positive, so we're not going to take anything out from it. But we are going to take out a common factor. I see 3 goes into all these numbers. Now let's take a look at the common x's. Well, there's 3 here. There's 1 here. But there's no x's here. We can't take out any x's. So we just have to only be able to take out a 3. So that's it. That's the only number. And so 3 goes on the outside, and then we do the division. So 3 goes into this 3 one time, so we just have our x's left over, so x to the third. 3 goes into 9 3 times, so we're left with a minus 3x. And then this 3 goes into this 3 one time, so we're left with a negative 1. So when everything cancels, we still need to put that 1. Otherwise, we wouldn't have the same number when we multiplied out. If we didn't put this 1 here, we'd only have a binomial. But when we're factoring, we should always have the same number. If we're factoring out a common factor, we should always have the same number of terms at the end, another trinomial. Well, one more problem here to try. This one's a little different because it's not in descending order. Look at it. N to the third, n to the second. Let's rewrite this. I'm going to rewrite this as 14n to the third minus the 7n squared. See, notice I took this term and just with the sign, and I'm just putting it in front of this 7n with the sign and all. All right, well, let's go ahead and take out the common factor between these terms. So looking at the 14, the 7, and the 7, 7 goes into all of these numbers. And how many variables go into them? See, sometimes we have some, sometimes we have none, so it all depends. See, here we have 3 n's, here we have 2, here we only have 1, so all we can take out is 1 n. Again, the whole concept was if we took out more, like n to the second or n to the third, we would have n's left on the bottom of the fraction, and you can't have that with polynomials. You can only have n's or any variable to a positive power. So we go ahead and do some work here. We have 7 going into 14 2 times. So again, we put that 7 in on the outside, and we have 2 left over. Count up the n's. 1 n gets taken away from the bottom. We take 1 from the top, leaving us with 2 n's, n squared. Here, this 7 will cancel out this 7. Remember, there's always a number left. We have 1, so it's going to be a minus, and then we have 1, and then how many n's? Well, 1n takes away 1n from the top, leaving us with 1n. So you could write the answer as minus 1n or just minus n. And then here, the 7's cancel out, and the n's cancel out. But we have to have a number there, just like we did over here. So we have to put that plus 1. If everything cancels, you still have 1 left over. So there is our answer. Here's our other one. Well, what we're going to be doing next is factoring out a common binomial, which will lead to another concept called factoring by grouping, which we'll see tomorrow.